We're going to talk about how to use the z-score, or how to find z-scores using the z-value table from the normal distribution. And the last time we talked about the normal distribution and the normal curve, we're going to get a little more in depth with that and talk about specific values. So, first thing we're going to talk about is how to use this table, the table over here, and how to find specific values so you can find certain probabilities and chances or percentages of things that are going to happen. So for exercise 1, it says boys' heights in 7th grade are normally distributed with a mean height of 62, standard deviation of 3.2 inches. So they want us to find the z-score rounded to the nearest hundredth for each of the following heights. And they want us to show the calculation that leads to our answer. So we're going to use this formula up here. So to find that z-score, we have to take our value, whatever we're asked to find. In this case, the first one's 66. We are going to subtract it from the mean. And in this case, the mean was 62. And then we're going to divide it by the standard deviation, which is 3.2. So they want us to find that z-score. So in the case of this, I'm going to take my calculator. I'm going to go ahead and I'm going to do alpha y equals. I got 66 minus 62 over 3.2. I'm going to round this to the nearest hundredth. In this case, I don't need to, but the z-score would be 1.25. And we're going to look at one of the other ones. Let's look at B. In this case, you have 57 minus 62 over 3.2. So I'm going to go ahead and hit second enter. I'm going to go back up and change that. 66 to 57. So in this case, looks like we've got negative 1.56. So now what we're going to do is we're going to talk about, that is our z-score. So those are the answers for A and B. But now what we're going to talk about is we're going to talk about how to find what the decimal value for the percentages that these numbers fall at. So you notice that it says 1.25 for this first one. So to find 1.25 on this chart, you go to the z-value for the first two digits, which is 1.2, and then you go over to 0.05. So in this case, this value, 0.3944, that means that for 66, that's how far we are from that middle line. So in this case, we are 39.44% from the mean for 1.2. So we got 39 numbers between the mean and that value, 1.25 for the z-score. Now for the other one, negative 1.56, what you want to do is go to negative, or in this case 1.5, which is here. Go to the 6 value, the 0.06, which would be this one. And that is 0.4406 away from that mean. Now the fact that it's negative means it's on the left side. So when we're talking about that normal distribution, which we talked about in the previous assignment, which I'm going to pull up, one thing to think about, if you're talking about 1.25, you're talking about the value right in here. So 0.3944, that represents this distance. Okay. Now, if we wanted to figure out how many people were below that mark of 66, well, we'd have the 0.3944. We'd also have this half, which is 0.5. So as far as a percentile goes, or a percentage, that 1.25 is going to be 0.8944 total, or 89.44% of the data. And in the case of the negative 1.56, well, that negative 1.56 is going to fall somewhere in here. So what that means is that from here, I'll do this one in red, from here to the mean, there's 0.4406, or about 44% of the numbers. Which means if we were talking about how many more, or how much larger is this, or how many more people are larger than that, you'd have to go ahead and add those amounts together and subtract it from that 0.4406. So if I wanted to find that, it'd be 0.5 minus 0.4406. And in this case, you'd end up with a total of 0.594, or 0.0594, which would be 5.94%. So we're going to look at some examples like this, dealing with these values. So if we go ahead and take a look at exercise 3, I'm going to go ahead and make this a little larger right now. So they want us to find the z-scores for 25 and 32. So we got a mean of 29.2 and a standard deviation of 2.4. So I'll do the 25 first. And then I'll do the 32 second. Now I'm going to go ahead, in this case, pull the calculator out. So we got 25 minus 29.2, and I should have did a fraction, alpha y equals 25 minus 29.2 divided by 2.4. That gives me negative 1.75. And then I want to do 32. So I'm going to change that 25 to a 32. So it's going to get 1.17, round to the nearest hundredth. So I'm going to go back to that table now. It says they want us to use the z-score table to determine the proportion to the nearest percent that lies between 25 and 32. So again, what we have right now, if you're talking about that z-score table, and I'll look at the normal distribution first, we're looking for the parts between 1.17, which would fall about right here, and negative 1.75, which would be about here. So we're talking about this percentage. So we need to figure out how far this is from the mean, and then figure out how far that part is from the mean, and add those two together. So if I go to the page we were just on, and I find those amounts, I got negative 1.75. So let's go to 1.7 here, and then in that case, the 0.05 would be 0.4599. So it's about 46%, just underneath it. Then we got to do 1.17, 1.1, go to the 0.07, 0.3790. Now I want that total amount. I'm going to add these together in this case. And do a little old school here. Looks like we end up with 0.8389. And it said in the question to the nearest percent, so that would be 84% in that case. So a lot of these questions, you need to find those z-scores and determine what part of that normal curve are you trying to find the answer for. In this case, we got to add both those together. So as you work through, I'd like you to look at exercise 4 and try to do a couple of those A, B, C, and D in exercise 4, and let me check it before you get into the questions.